This tutorial video is one in a series of several that involve solution stoichiometry. This is the beginning type of question that you see in solution stoichiometry. Now we saw in Chapter 3 that stoichiometry problems involve unit conversions. The main thing that you have to remember in stoichiometry problems is you have to use the mole ratio that comes from the coefficients in the balanced chemical equations. And since that ratio is in moles, whatever units you're given in to start the problem, you have to convert those first into moles so you can use the ratio. In the big picture, once you start seeing how stoichiometry problems can be treated just like a series of conversion problems, then it gets a little bit easier. But until then, this can be challenging to make your way through the problem. So this question says how many milliliters of 0.457 molar phosphoric acid could be completely neutralized by 45 milliliters of 0.1 molar KOH. So we have an acid-base reaction here. They're giving us the amount of KOH that we have, 45 milliliters of a 0.1 molar solution, and they're asking us how many milliliters we need of this particular phosphoric acid solution. So what you need to remember is that if you're given volume, milliliters, and concentration, molarity, you can come up with the number of moles. Remember, that's what we need to use the ratio from the balanced equation to connect KOH to H3PO4, or phosphoric acid. So in solution stoichiometry, you're going to start with the volume, so the 45 milliliters, but it has to be in liters, so divide by 1,000, or another way to do that is move the decimal place 3 places to the left. The reason we have to be in liters is because we're going to use molarity, and molarity tells us the ratio of moles of the solute for liters of the solution, and so we need to be in liters and not milliliters. So the second thing then, once we have the moles, we're going to take that and multiply it by the concentration of the KOH. You see this word "of" there connects these two. So when I'm in stoichiometry problems, when I'm solving them, I don't think of it in terms of molarity. I think it's 1.100 moles of KOH in 1 liter of the solution. Now just looking, remember stoichiometry problems are conversion problems. My liters cancel, and so by multiplying volume times the concentration, I end up with moles. Now that I have moles of KOH, I can use the ratio from the balanced chemical equation, which is 3 moles of KOH to 1 mole of phosphoric acid, in order to convert to moles of phosphoric acid. So I'm going to multiply by the mole ratio. I'm going to put the 3 moles of KOH in the denominator, again, so it will cancel, and the 1 mole of phosphoric acid in the numerator. Again, I'm driven by this series of conversions, so moles of KOH cancels. Once we have moles of the phosphoric acid, then we can use the concentration of the phosphoric acid to connect it back to volume. We want milliliters. Now remember, 0.0475 molar means 0.0475 moles per liter. So I'm going to write this as 0.0475, I ran out of room, moles of H3PO4 in 1 liter of solution. So I'm using the concentration unit as a conversion factor. So I put the concentration, the 0.0475 mole of the H3PO4 on the bottom so that it would cancel. Now if I get this answer, if you look here, I would be in liters, and the question asks for milliliters. So then coming down here, if I say 1,000 milliliters in 1 liter, then I will have my answer. So what you're going to do to solve it, if you remember, is take the 0.0450 liters, multiply it by 0.1, then I'll come and I'm at the ratio now, I'll divide by 3, and I'll divide by 0.0475. That would give me the liters, and so multiplying by 1,000, I get to 3 significant figures, 31.6 milliliters of H3PO4. So basically, reviewing the problem, I started with the volume and the molarity of the KOH that I was given, and by multiplying the volume times the molarity, I ended up with moles of KOH. Then I multiplied by the ratio of what I was looking for, the phosphoric acid divided by the KOH, and then that gave me moles of phosphoric acid. To change moles of phosphoric acid into a volume, I divided by the molar mass of the phosphoric acid, which was what I was given. The final step was to convert the liters, which is the unit I get from the concentration, into milliliters by multiplying by 1,000. So the answer to my question that I was given is 31.6 milliliters of phosphoric acid would be required to completely neutralize 45 milliliters of the 0.1 molar potassium hydroxide.